Hi everyone, welcome to JavaTechie. Transactions are the backbone of any enterprise application. Whether you are processing the payment, updating the inventory, or managing user details, ensuring that everything happens consistently is always critical. In real world application, it's common to execute multiple database operations in a single method or in a single use case. But what happens when something goes wrong? How do you ensure that one failure does not break the entire system? That's where transaction management comes into the picture. So, in this tutorial, we'll dive deep into Spring Transaction Management, exploring how it works and why it's essential. Plus, we'll also cover different isolation and propagation level with hands-on example. Okay? Alright. So, without any further delay, let's get started. So before we directly jump into the code, let's first go through the use case to understand what is transaction and why do we need it in real-time application. Okay, then we'll implement the transaction step by step. So first, let's begin with a real-time use case. So imagine you are working in a e-commerce project where you have the inventory service and it contains a product table with ID and what is the name of the product and what is the price of each product and then what is the available stock of that particular product in inventory. Fine. Now let's think user want to place a order. When user want to place a order, let's say user want to place laptop whose product ID is 1 and you want to purchase 2 laptop. Now at first step what you will do, you will first save the order DB. Let's say order ID is 101, product ID you want to purchase laptop whose ID is 1 and quantity is 2. Then what is the amount? Amount is nothing, each product is 25k, so 2 product means 50k. So at first step, this is the first step. You save the order request to the order table. Then in second step, what you want to do, you also need to update the stock in inventory. Initially it was 10. User purchased 2 product. Then the stock value will be 8. Okay. That is what also you need to update. So once you are done with that update, then you need to also update the payment database. Let's say this is the payment DB, this is the third step. So here to place an order we are performing 3 DB operation. First one, persist it to the order DB. Second one, update the stock in inventory system. Third one, save the payment information. Now let's say we have received another request of purchasing the laptop again and user want to purchase 5 laptop. Okay, so first step what we will do, we'll update the order DB. Let's say order ID is 102, product ID user want to purchase 1. How many order you want to purchase? Quantity is 5. Then what will be the price? Each product price is 25k. Based on that the price will be 1.25 lakh. So we save the record, right? Now what next? We are going to update the inventory system. It is 8 currently. We want to update it to the 3 because user already purchased 5 record. But imagine while updating in the inventory system there is a failure. It could be a network glitch or it could be some DB connection issue in the inventory server. So there is some issue. We cannot update the stock price in inventory now. Then next step also we cannot perform, right? But if you observe, we already saved this record to our order DB. However, we are unable to update the stock value which supposed to update as a 3 because of the failure in the inventory service we cannot update it. Okay, but still we have this unused data in our database. Now what is the problem here? Let's say user want to search in the catalog service you want to search the product, that is laptop. Okay, what is the count it will show to the user? 8, because it is available 8 product in the inventory, because the value is not update. It means the data in the order db and inventory service is not consistent. Okay, so there is a data inconsistency issue in my order db and inventory service, so which can break my system. So in such scenario, what I want, I don't want to keep the unused data. Rather, what I want to do, if anything going wrong as part of my flow, I want to completely roll back all the changes. Even I don't need this record in my DB. If there is a failure going on in my single flow, then I want to roll back everything. I want to revert everything from my all the dependent database. Otherwise, if all going good, then just commit that changes. That is what all about transaction. Okay, this is the simple principle of transaction. If anything going wrong in a flow, just roll back everything. If all good, then just commit them to the database. Fine. So I hope you got some concrete picture about what is transaction and why we need transaction in our application. So we understand the problem that if while placing the order, if there is a failure on any flow, then the data will be inconsistent in my application. To overcome that, we can go for transaction, so that if there is any failure, then roll back. If failure, okay, otherwise commit if everything succeeded. Those things will be handled by transaction. Okay, so don't worry, we'll discuss the same use case. We'll create the order db and inventory db, then we'll try to replicate the same use case what we have discussed in this flow to understand the need of transaction in real time. Okay, so let's go to the IntelliJ idea and let's create the project. So to save our time, already I created the template of Spring transaction example. I have not write any use case or implementation. I have just created the template. Let me walk you through the code. So far what I have done here. First go to the pom.xml. We are using latest version 3.4.0 and JDK version 21. Then we added the Spring Bootstarter Data JPA, Web Dependency, MySQL Connector, Lombok, and also I added the Open API to use the Swagger. Okay. Apart from that, I also created the entity class what we discuss in our flow, order with the ID, product ID, quantity and total price, product which is nothing, your inventory product details, we have ID, name, price and stock quantity. Fine. Now I have created corresponding repository for order for inventory. Then I have created a handler class called order handler, where we are just using the save order object. Okay, so I am directly using order repository dot save and pass the order object. Similarly, in inventory, I have the fetch the product from the inventory and then save the product. Okay, these are the simple logic I have written in handler class. Then we'll write the actual logic in our order processing service. So in order processing service, I injected both the handler class, then we'll write our logic to place an order. Okay, so public so this is the operation we are going to perform here. Okay, so if you understand the flow, we discuss the same use case, order db and inventory db, and we are performing 2 db operation 1 and 2. So let's do the same here. Go to the IntelliJ. Now let me note down the step what we are going to do. So I am trying to demonstrate this without transaction and with transaction with a real time use case. so that upcoming video when I will explain the propagation and isolation, we can come up with different real-time use case rather than just print the statement. Okay, so that is the reason I consider this particular use case. So first let me note down the steps we are going to perform. First we will get the product from the inventory. Once you get the product from inventory, then next you can validate stock availability. It means, let's say in inventory I have 5 product, let's say I have 5 laptop. User cannot send quantity as a 6 while he place an order. Okay, so the quantity from the order request should be less than the stock availability available in my inventory. Next you can update the total price. Let's say laptop price is 25,000, that is what we have discussed here, right? Let's say laptop price is 25,000. If user purchased 2 laptop, then it should be 50k. So this amount will update here. Update total price in order request or order entity. Fine. Once you are done with that, save the order. Then the last step, update stock in inventory. Fine. These are the steps we are going to perform. So let's go step by step. First, get the product from the inventory. So I will use inventory handler dot get product, give the product ID. So you will get it from the order request product ID. What it will give you? It will give you the product object, product from the inventory. The first step is done. Now what is the second step? Validate the stock availability. Now we need to check if the quantity given by the order request, if it is greater than the stock available in inventory product dot get stock quantity, then simply throw some exception. I'm just throwing runtime here. Fine. We validate the stock availability. Next, just update the total price. So you can do order dot set total price. How can you evaluate the total price? The number of order or the order quantity into price from the product. So you can do something like this: order dot get quantity into what is the price of each product, you will get it from the inventory. Okay, this is how you can update the total price of your complete order. Now just save the order. So you can use order handler dot save order. Just define the local variable. I will return the same order object. Okay. Now once you update the order, next you can update the inventory, stock in inventory. How you can update the stock? Nothing. What is the stock available earlier minus the quantity user purchased. Okay. So just do available stock. You can, how you will figure it out? First get the total stock available in the inventory, inventory handler, or you can directly get it from the product, right? Product dot get stock quantity, then subtract how much user purchased. Okay, so you can get it from order dot get quantity. Let's say earlier it was 10, now user purchased 2 order, then it should be 8, like that. Fine. Then just update it to the product dot set stock quantity, which is nothing, the available stock. Then just update the inventory. Call the inventory handler dot update, pass the new product. Okay. We define all the required step. Now for better coding practice, what we can do, let's move this logic to a private method. So extract them to a method. I'll just name the method update inventory stock. Then here also I'll keep it private method. So this looks good now, right? So we have defined all the steps. Now just access this particular method from controller so that we can test it. Go to the controller class. Again, there is no logic. I have just defined the empty endpoint. So what we can do, we can simply call here new response entity, then just we can use dot OK and just call the method. So we can use order processing service dot place an order, pass the order request. All looks good now. Now let's run our application. This we are testing without transaction. We'll see the happy scenario, then we'll see the problem, then we'll understand how transaction helps to overcome that problem. Fine, that is the simple way we can validate now. All good. Now let me see what I have defined in my properties file. The port will run on 9191. Go to the main class, just run the application. So you can see here application started on port 9191 and also it created the table orders and product. Now let's validate the same. Just refresh the schema. You can see the table here, right? So let's check the record in these two tables. So there is no record in the product, even there is no record in the order table. So we want to add few record in the product table to execute our place an order, because at the first step we are getting the product from the inventory, right? So let me add few record. Now if you check the product, you have two product ID 1 and 2, name laptop, smartphone, price 25,000, 5,000, stock quantity, availability. See these two numbers. There are 10 laptop available, not laptop, yeah, there are 10 laptop available in the inventory, 12 smartphone is available in the inventory. That's the simple thing. Okay, now what I'll do, I will just open the Swagger. Now I'll just place an order. Let's say order ID is 101, product ID, what you want to purchase. Let's say I want to purchase this laptop. Okay, just pass the order ID, which is 1, not order ID, product ID. Okay, now what is the number of laptop you want to purchase? Let's say I want to purchase 2 laptop. What is the total price? It will be generated in my code. Just remove it. Now if I'll send the request to execute that endpoint, let's see the result. We got the result, product ID 101, order ID 101, product ID is 1, quantity 2. What is the total price? Can you see the price here? 50,000, because each product is 25,000. So we are purchasing 2 quantity, so it will be multiplied. Now let's validate the same in our DV. So these are the two product constant. First let me show you the order, then we'll come back to the product again. So this is the order entity, right? Now initially the stock availability in product for laptop was 10. Since we purchased 2, it was changed to 8. Now if someone will check in the catalog service, hey, I want to see the number of available laptop whose price is 25,000, it will display 8 in the UI. That is fine. We just discussed the happy scenario. Now let's try to break the flow. So just go to the inventory handler, what I want to do, let's say while update the product details, I'll forcefully throw some error. Okay, assume you will get some db crash error or some error in real time, but I cannot do that. So for that reason I am just forcefully throwing some exception. Okay, let's say I just want to check if product dot get some field, guys. Okay, price greater than 25,000, let's say, then I want to throw some exception. I'll give the meaningful message. Okay, let's say db crashed or something like that. Just a note. Fine. So here we are trying to replicate the same use case what we discussed. So when user will purchase the order or place an order, the request will save in the order table, but assume you are getting some error in inventory system. So that is the reason in inventory handler I forcefully throw some error to simulate the transaction behavior. Okay, better let's change it to 5,000 to throw the error. If you'll keep 25,000, then definitely there will be no error, because if you'll purchase laptop the price will be 25,000. Okay, so change it to 5,000, that will throw the error. Just restart the app quickly. So application started. Now just validate the dv once. So we have laptop of 8 and other one is 12. Then if we'll check the order, we must have a single order. Yes, we have the last order which we inserted. Now let's do one thing. Just go to our Swagger and I'll insert another order of laptop only. Let's keep the product ID as 1. I want to purchase the 5 laptop now. Okay, so for your information, let me keep a note of it. Initially it was 10. Now at first time I purchased 2. Second time now I am trying to purchase 5. Okay, now let's do one thing. Let's trigger the request. Now what will happen, as per the flow we understand, the record will be inserted to the order db. Then we'll see whether record is getting update to the inventory table or not, inventory product table or not. Now if you'll check, there is some exception. What is that exception? Let's see. Assume db crashed, because while updating in the inventory we forcefully throw the error. That is nothing, db crashed, the same error. Now let's validate in our db. First let's check the order table. Great, we got the order request entry here. 102, product ID 1, which is nothing the laptop, quantity is 5. So 125 total price. Okay, now if we'll check the product, see the magic here. In inventory still it is showing 8, because while purchasing this order of 5 we got the error. Because of that error or exception, the inventory is not up to date. It means my data is not consistency across my application. Now what problem it will create in future? Now when user will come and check for this particular laptop of product ID 1, it will show the number as 8. However, in reality the order is dispatched out of 8. Now the total available product is 3, but still it will show to 8. Still it will show 8 to user, which will cause the overselling issue, and customer can be angry on your product or angry on your system. He might not be happy on your application, saying that okay, it is showing me 8 product available, but when I am purchasing that it is crying, saying that hey, I can't give you the product what you are requesting to me because I don't have available. Then why don't you update in your catalog service? Why don't you update your stock quantity in inventory? That is what the problem this can raise in future. Okay, so it must need to update. if you place the order, make sure you need to update the inventory. If there is some error while updating the inventory, then you must need to revert this entry from your order table as well, saying that at this moment we cannot consider your request, please try after later, or something. You can give the valid fault message to the end user rather than keeping this unused record. Okay, now how we can avoid this? So to overcome this kind of data inconsistency issue, Spring Framework provided a concept of transaction by just giving a annotation @transactional. Okay, so you need to play with this annotation to avoid data inconsistency issue in your application. Now let me show you how you can play with transaction. So till this point we understand what is transaction and why transaction. How to use it I will explain now. Okay, just go to your service. Now this is the method place an order who is doing multiple DB operation. When I am saying multiple DB operation, transaction will always applicable for insert and update and delete, not for the fetch. Okay, so in place an order, what we are doing? We are updating, we are persisting the order request to order entity, and also we are updating the stock in inventory. These are the two save and update operation we are doing in a single flow. Now what I want, if anything going wrong while updating the inventory, then also revert the changes from order table. Don't keep unused or stale data in my application, so that in future I will get the issue. Okay, to make the system stable, better revert at the moment when you get the failure. Okay, that is what the simple principle of transaction. Now how you can use the transaction now? Simple, just use the annotation transactional. There are two transactional annotation you can see, one from Jakarta, one from org.springframework.transaction.annotation. Just use the second one. Okay, then insert this transactional, you have so many attributes. Read only, by default it is false. You can see here read only equal to false, which is the default. It means this particular method where I am implementing the transactional is not only doing read operation, rather what it is doing, it is doing the save and update operation. Okay, so you need to keep the read only false. Now if I will keep the read only true, this method will give me the exception. When you are defining read only true, transaction expecting, hey, you must need to define the fetch or get method or select method. Okay, so by default it is false. Then there is a property called propagation. Can you see here propagation? Let me define the propagation first. Currently I will use the default one, which is propagation required. Okay, so what this propagation does at high level, if you will understand, propagation deal with how multiple transactions can communicate with each other. Okay, you no need to go deep at this moment. As I mentioned from the beginning, I will cover each and every propagation and isolation level in details with proof in my upcoming video. Okay, so keep it propagation required. Then you can define isolation. Isolation default is default, but no one is using that. It is specific to the DB what you are using. I'll just use read committed. Again, what do you mean by isolation? Isolation controls how one transaction see the changes made by another transaction. Okay, whether you want to read the committed data, or you want to read the uncommitted data, or you want to do the repeatable read or serializable read, there are different type of isolation. Okay, so let's go with the default attribute or default value of each and every attribute at this moment. Okay, So you can remove this. By default it is false, so you no need to define it. Now let's see the magic. We'll run the code and we'll see the magic now. Okay. Now let me restart the application. So it started. Now what I'll do, first I'll go to the DB. I will first remove this manually. Okay. This is completely useless for me or for my application. So I'll just delete the record whose ID is 102. Fine. Now if we'll check the order table, you have a single record. Now if we'll check the product table, you have a single record. I mean two record, laptop and smartphone, all are unique, the value is updated. Now what we'll do, let's test our flow. Now we are testing with transaction. Okay. So go to the Swagger, let's say ID is 2. Now I want to purchase the smartphone. Okay. 2 quantity, let's say what is the available quantity I have, 12, right? I want to purchase 7. Now just click on execute. So if you observe, there is a insert operation, there is a update operation without any failure, because if you see the request, product ID 2, the quantity is 7. This is the 2 and 7, right? So if you check in the DB, this 2, which is nothing the smartphone, that price is 5,000. Each individual product price is 5,000. And earlier it was 12, correct? It was 12, right? So when we purchased, how much? 7. Correct. It is 5 now. That is correct. This is happy scenario. We didn't get any error, because what we are forcefully throwing the error here, if you check here in the inventory, we are checking the, where it went, in inventory handler, right? We are checking the price is 5,000, but we are giving the price as a 5,000 because each mobile or smartphone price is 5,000, so we won't get any error here. You can reduce the number to validate or test your smartphone use case, but let's go with the laptop use case because that price is 25,000, which is more than 5,000, right? So go here and try 103 product ID. Again I will come to the laptop 1 and I want to purchase 5 quantity. Okay, now click on execute, come here, go to the console. We got the error. What is that error? DB crashed. Now go to the DB and just validate. Let's say I want to check the order DB first, order table. Can you see the record? 103 and the product ID 1, quantity is 5 and price is 1,25,000. No record is inserted, right? Now if you'll see the product table, which is nothing my inventory table, does it update the count? Let's see. No, still it is 8. In this case, since we found there is a failure, we are performing 2 DB operation. One, we are persisting the record to order table, and second one, we are updating the inventory. Since we found the problem in one flow, we revert everything. Even we don't keep that unused record in my order table as well. We have not inserted the unused record because for that record, when we are trying to update the inventory system, we found the failure. So for that reason, to maintain consistency, we removed all the record, all the dependent record from different database. Okay. Now in this case, what happened? When a user will check the product in catalog service, let's say you want to check for laptop whose price is 25,000, it will give the correct count to him. Now he will get 8 because that is what available in the stock, that is what available in my inventory system, correct? Now my data is consistency across my application. I will not get any overselling issue. Okay, so that is the main purpose of using transaction to avoid data inconsistency and to maintain data integrity in your application. Okay, so this is what all about what is transaction, why transaction, and how to use transaction in Spring framework. So this is just basic use of transaction we understand here. In my upcoming tutorial, I will cover each isolation and propagation label. So if you see here, there are 7 or 8 propagation label. Can you see here? Required, supports, mandatory, required new, not supported, neighbor, nested. Okay. Since they have defined different type of propagation label, each and every label must have their some use case, right? When I will go for required, when I will go for required new, when I will go for nested, or when I will go for mandatory. You should know that rather than just knowing the theory about what is propagation and what is the default one and how can I use it. Similarly, if you'll check the isolation, if you'll go back and if you'll check the isolation, you will find 1 2 3 4 5. This you can ignore. You can find 4 useful isolation label: read uncommitted, which is nothing your dirty read; read committed, but it will not stop the repeatable read, which will not, I mean, what I can say, which will not handle the phantom read. Okay, then last one is the serializable read. Okay, so there are again 4 type of isolation label we have. So in my upcoming tutorial, I will cover each and every propagation label and isolation label with real-time use case. So I hope this particular use case plays an order by defining transactional, propagation and isolation. We also see the problem with the transaction, then how we solve it using the transaction, right? So just give a try with different use case and do let me know in a comment section if you have any doubt or open question. That's all about this particular video, guys. Thanks for watching this video. Meet you soon with a new concept.